I'm Dory, and I'm answering a question from SolarX. SolarX would like to know, why are there different elements? According to the Big Bang Theory, the first pieces of matter cooled to form hydrogen atoms. So, why didn't they all just stay hydrogen atoms? It comes down to the stars formed by this hydrogen. This hydrogen experiences scorching temperatures while being under extreme pressure due to the mass of the star. The atoms have a ton of energy packed into a dense space, so what happens to them? They fuse in a process called nucleosynthesis. Astrophysicists concluded that if 4 protons, the equivalent of 4 hydrogen atoms, have more mass than 1 helium atom, then some of this missing mass must be converted to energy. Wait a minute, didn't we say at Starbase that matter and energy can't be created or destroyed? Well, based on the equation E equals mc squared, we can convert mass to energy and vice versa, but only under the right conditions. The conditions we are looking for exist in these stars. Stars are giant sites of nuclear reactions where particles can interact and fuse to form new elements while converting the extra mass into energy. 2 protons fusing with 2 neutrons will create helium. If a pair of helium nuclei fuse, you get beryllium. Add another helium to that beryllium, and there's some carbon. The process can continue up until iron. Why does it stop there? By the time we get to iron, the star uses more energy to form the iron than is needed to continue the chain reaction. In other words, the star would use up all its energy and die out. It is so inefficient to make iron that this only happens in stars 8 times the size of our Sun. Then how do we explain the heavier elements? Those come into being under even weirder conditions, like when the core of a star collapses into a supernova and it ejects the new elements into the surrounding space. Supernovas are also release enormous amounts of neutrons and light energy when they explode. These neutrons are absorbed by other nuclei to form larger elements as well. The nuclei tend to be fairly stable until they reach a mass of 270 atomic mass units, or 270 protons and neutrons together. After that point, the nuclei break down into smaller elements that are more stable. This explains why we can find elements with masses in the 250 atomic mass unit range compared to iron, which is 55 to 56 atomic mass units. There are even some elements that we couldn't find in nature, but have generated in nuclear reactions and particle accelerators. Of the 118 known elements, only 92 of them can be naturally found on Earth. These other 26 still require a lot of energy to form, and many don't last long before breaking down into smaller elements. So there you have it, SolarX. We have many different elements because under the right conditions, the nuclei of simpler elements fuse together to form new and larger ones. Thanks for watching this episode of Ask Starbase, and a special thank you to SolarX for asking this question. If you have a STEM question, please email it to ask@starbase-ct.com, or you can send it into our website, starbase-ct.com. Stay safe and be well. Bye!